All right, and then let's knock this last video out. Lines of symmetry or reflectional symmetry. A line of symmetry is a line across which half of the figure could be reflected in order to produce a whole figure. For example, the square shown here has 4 lines of symmetry. So your cell phone screen actually works as a great mirror. If you put your cell phone screen here, or a mirror in general, here, here, or here, the square would look the same exact. All right, and what's important is that we don't double count the lines, because some students would say, oh, well, there's 8. No, there's only 1, 2, 3, 4 lines. Only 4 unique lines. All right, so here's a tri-diagram, or Venn diagram with 3 half the Olympic rings. So what I like to think, to use some logic here, think about like the outermost points. These are like the outermost points combined with the innermost points. All right. So using logic and thinking about things, and can say, well, if I put a mirror right here, this image would still look the same exact. If I put a mirror right here, this image would look the same exact. And then the last place is I could also put a mirror on this line. So this tri-Venn diagram has 3 lines of reflectional symmetry. So I like this next problem. This problem is a really good problem. Why is this problem a good problem? Because we got the teeth. Basically, just put the teeth with the teeth. All right. This gear has 8 teeth. So it has 4. And put that in parentheses. It has 4 lines of reflectional symmetry. Why did I put that in parentheses though? Because you actually can go between the teeth as well. So actually right here, this orange line, if I put a mirror on that orange line, it would still look the same. Same with that orange line, and that orange line. So you can match up a mirror on the teeth or inside the teeth. And you get a total of 8. Now this one next right here, let's see. If you put a mirror right here, notice how then this triangle down here would look like that, and this triangle up here would look like that. So the triangles would be oriented differently, so that doesn't work. A square above had 4. This one though, if I put a mirror here, well then this triangle would look like that, and then that would look like that. So no, that doesn't work either. In fact, this one, if you can find a line of reflectional symmetry, you get an A+ for the whole year. Because this one actually has 0 lines of reflectional symmetry. There's nowhere you can put a mirror and this figure would look the same. Now a circle has infinite lines of reflectional symmetry, but this tire has a little detail, has the bolts. All right, so if we go from bolt to bolt, let's see how many bolts are there. We're already at 4. Kind of missed, but oh well. So we're at 1, 2, 3, 4, 5, 6. And remember, we don't want to double count our lines. And also, we can go between the bolts. So the next one would be 7, 8, 9, 10, 11, 12. We don't want to double count. So this one has 12 total lines of reflectional symmetry. And then we got this one. This actually has a geometric name. The geometric name for this one is a kite. And this kite only has 1 line of reflectional symmetry. If you put a mirror right there, it would still look the same exact. All right, so that's it for reflectional symmetry. for fun, I'm not going to do this on a video, but you can reflect the cat's face over here. So mine's going to look kind of ugly because I'm just going to, like, I'm not even matching up the points. But realize that the goofy eyebrows would be close, and then the squirmy eyebrows would be far away. Like, notice how that's how the line of reflection's got to be. Also with this pirate, because I know sometimes students just try to trace it and then reflect it. Notability doesn't look like that. The earring will be over here, and the eye patch will be over here, and then his hat, like, oops, I messed that up. Would be something like that. All right. You can spend a little bit more time on that. This is just a little fun. We got the cat and the pirate, and then some follow-up canvas problems. Wow. Mario. I love that guy.